Let's take a look at topic 2.5, example 1. We're going to use square roots to solve quadratics. So here's my equation, and I want to solve to find x. I have a quadratic over on the left side. I'm going to go ahead and factor that. I see I have a leading coefficient of 1, so I'm just going to go ahead and drop my set of parentheses in. My C value is positive. That tells me the signs of my factors will be the same. If I look at the middle term, that's going to tell me what they are. These are both going to be pluses. I can go ahead and drop my x's in. And I need to find two numbers. When you multiply them, you get 49. But you add them, you get 14. Well, 7 times 7 is 49, and 7 plus 7 is 14. Now notice, x plus 7 is just a number. If I were to say 3 times 3, we could easily write that as 3 squared. 5 times 5, 5 squared. So whenever you are multiplying a number by itself, you are squaring it. So let's write this as a square. X plus 7 squared equals 25. Now I'm solving for x. I need to get rid of this square. The inverse operation of a square is a square root. I'm going to have a plus minus square root of 25. Okay. I'm now left with x plus 7 equals plus or minus the square root of 25. I'm not going to simplify it just yet. Now here's a very important step. When you move a constant over to the other side, you need to make sure you put it to the left of the plus minus. So I'm going to subtract 7 from both sides, and I get x equals negative 7 plus or minus the square root of 25. And I'm going to simplify. Okay. Now, this tells me I have two different solutions. Remember, when we're finding solutions of a quadratic, we're looking for the x-intercepts. So this graph is going to cross the x-intercept in two places. We have x equals negative 7 plus 5, and then we'd also have x equals negative 7 minus 5. So here we go. X equals negative 7 plus 5 is a negative 2. So there is one solution, one x-intercept. And here, negative 7 minus 5 is a negative 12. And that is my second x-intercept.